Hello everyone, and welcome to the Game Engine programming series where we write a game engine from scratch. The last episode was all about the content browser, where we created the logics and designed the UI for something that's similar to Windows File Explorer. This episode is a second iteration that's meant to improve the code architecture and hopefully gets rid of some rough edges in our current design. In this video, I'll focus on the architecture part, and in the next video, we'll use the content browser to save procedurally generated geometry assets. Before we start, I'm going to do a couple of quick fixes for small mistakes I made in the last episode. In content info's constructor, I need to use a function parameter instead of the property. I also made a typo in this method's name, so let's fix it. And finally, I for some reason added an extra line about grid column attach property in this path style, which obviously we don't need, so I'll remove it. That's all for fixes. Everything seems to be working fine, which is excellent. As I mentioned in the intro of this video, we need to improve the architecture of Content Browser's code, and by that I mean mostly the view model we see here. Looking closely at what it does, I can't but notice that it's trying to do too many different things at once. It's keeping track of content folder changes, it has a content cache which needs synchronization, and it holds the data for displaying the contents of the currently selected folder. This makes it hard to work with, at least for me, and it just doesn't feel right? Furthermore, we also have another content watcher in asset registry, which seems quite redundant to me. So what I'd like to do is to split the functionality into separate parts, which makes each part simpler to work with. I'd like to pull out the content info cache and put it in its own class. I also want to separate the file system watcher functionality so that it stands on its own. Now that we created files for both classes, let's start with implementing the content watcher. Because I am moving code from content browser class into this one, I'm going to switch between these files back and forth. I hope that won't be too distracting, and my apologies if it is. Okay, let's move the refresh timer and content watcher fields over to our new class. Also, please note that this is a static class, which will be used during the entire runtime of the level editor. In the static constructor, we attached the event handlers for file system events. Again, we can move this code over from the content browser. We also need an event handler for the refresh timer's triggered event. Note that if we want to use the same method to handle all events from File System Watcher, we need to use the base class for the different event args, which is the File System Event Args class. I also made a typo here, it should be triggered instead of trigger. Before writing these methods, I'm going to write a reset method, which is called when we open a new project. It is needed to set the content folder location, which of course is different for each project. Before resetting, we disable events from the file system watcher, because we don't want to be disturbed while switching projects. Then, if the content folder contains a string that is an existing path, we can set the path property of the file system watcher to that location and re-enable the file system events. Now, where we are loading the project, instead of calling asset registry reset, we call content watcher reset. Because we are handling the events in this class, we need to have our own event which can be used by others to get notified about any changes that happen within the content folder. So we add an event, and we also need to have the proper carrier for the event args, which I'll put at the top of this file. It's not really necessary to inherit from event args here, but this way it's more consistent with other event arg classes in .NET. Our class here has got just one property that contains the full path to the file or directory that was modified. Now, whenever we get notified that something was changed in the content folder, we trigger the refresh timer. Note that I made this method asynchronous, so the file system watcher can go its merry way watching the file system. In the refresh method, which is called after 250 milliseconds of inactivity, we first group all event arguments by full path, and then for each event we trigger our own content modified event. So, as you'll see later in this video, instead of having a refresh method in the asset registry, for example, we can get notified by content watcher's content modified event. We can now go ahead and remove these 3 lines because we already wrote them in Content Watcher class. Let's add one more feature to the Content Watcher which we didn't have before, and that's the ability to stop it from raising events. This is useful for when we drop a bunch of textures and or FBX files that consist of hundreds of meshes and embedded textures. In that case, the editor will import all those files in parallel, which will generate a lot of events, causing both the asset registry as well as the content browser to update way more frequently than needed. So here I'm going to add a counter which blocks all Content Watcher events if it's greater than 0. I'm not using a boolean here because, like I said, the editor will import files asynchronously, and therefore we can't determine when the entire operation of importing multiple files is done. Using a counter, each imported item can increase it when it starts and decrement it when it's done, and it only becomes 0 again when the last item has been saved to the hard drive. We can simply ask the refresh timer to call us back later if this counter is greater than 0. Next, when we reset the Content Watcher after opening a project, we also reset the asset registry, so it will register assets for the new project. And that's pretty much all for the Content Watcher class. Now we can attach an event handler to Content Watcher's content modified event in the content browser. The event handler will have the same name, but it has a different implementation, as you'll see in a minute. But first, let's not forget to detach it from content browser. Otherwise, it would cause a memory leak because the content browser wouldn't get destroyed and garbage collected properly. In the event handler, we again do nothing if the event didn't happen in the selected folder. Because Content Watcher can still raise events rapidly in a short time interval, we still need a refresh timer to refresh only if one of those events happened in the selected folder. So let's copy back the refresh timer and use it here as well. Now I can remove the old method. Note that the new onContentModified method is no longer asynchronous. I'll move these 2 methods up a bit so we can see the methods we are working on all together. As I mentioned, the event handler is not an asynchronous method, but we can get the folder content asynchronously by making getFolderContent asynchronous. This way the editor remains responsive even if fetching file data takes a longer time. Getting the folder content utilizes the content info cache, which makes for a nice transition from implementing Content Watcher to writing the content info cache class. This class is also static and we need the lock object to make it thread safe. Similar to what I did for Content Watcher, I'm moving the relevant data members from Content Browser to Content Info Cache class. I also add a new private field that indicates whether anything was changed in the cache, so we only save that information if it is dirty. Speaking of saving, we can also move the load and save cache methods over to this class. Let's remove the lock for now, since the class implementation will be slightly different. I'll include a few missing namespaces, which I do by pressing Ctrl plus dot keys on the keyboard and choosing the proper namespace to be added. Next, I put the file operations in the save cache method in a try catch block as well. After saving the file, we set isDirty to false to avoid saving the same data to the file multiple times. In the same fashion as Content Watcher and Asset Registry, we can add the reset method to reinitialize the cache data when we open a project. When reset is called, we first save the old cache if we had one and it was dirty, and then load the cache for the new project. We don't need to pass the cache file's location to the load and save methods, since _cache file path has this information. For convenience, I also add a save method that simply calls reset with an empty string. In Content Watcher, we need to call Content Info Cache Reset in the same way as we did for the Asset Registry. I didn't remove this Content Browser part from the namespace when I created this file, so let me correct that mistake. Now we can access Content Info Cache and call its reset method. Finally, we can remove everything that's related to cache info implementation from Content Browser class. When disposing an instance of Content Browser, we save the cache info, and as we know, it only writes to the cache file if it contains new information. Coming back to where we started, we can rewrite this overload of getContentFolder method, which makes it a lot simpler. But first, we need to have a method that creates and adds a new cache entry for each file. First, we get the file info for this file, and let me quickly also write an extension method to check if the path that we are given is a directory. So we can assert that this path is not a directory. Next, we move over the part that uses a cache dictionary. Here we cache the content info if it's not already in the cache or it's newer than the cached entry. In this case, we also set isDirty to true. Because we already got ourselves a content info, we can return it so that it can be used by the caller of this method. All we have to do now is simply call this method, which will get us the content info we need in the content browser. Obviously, we no longer need the lock here and we can remove it. I'm pleased to see that our content browser is now reduced to only 140-ish lines of code. The cache functionality is nicely tucked away, and the content watcher is also much easier to read. We do still need to remove the file system watcher used in our asset registry class. Fortunately, that's almost as easy as simply deleting lines of code. We also need to update the reset method. Again, we attach an event handler to content watcher's content modified event. This time, because this class is static, we only need to detach the event handler temporarily when we are opening another project. Let's also remove the clear method since we don't have a reason to call it separately. I moved the lines that cleared the registry, dictionary, and collection over to the reset method. We can get rid of this refresh method too, since we are not using a refresh timer here. In the event handler for content modified event, we recursively register assets if the full path parameter is a folder. Otherwise, it's a file and needs to be registered. At the end, we unregister all registered assets that don't exist. I believe that concludes the changes in asset registry. Now let's see if the content browser still works. It displays the content correctly, but watch what happens when I create a new folder. Nothing happens. So either the content watcher has an issue or the content browser is not handling the events correctly. Let's investigate. Setting a breakpoint in the event handler, we see that's not getting called by content watcher. So I'll set another breakpoint in content watcher's refresh method and step through the code. Here we can see that content modified is not no, which means that it does have event handlers attached to it. So why isn't it calling any of those event handlers? Let me check what's actually in the data array that contains the list of file system events. Aha! The list is empty and therefore none of the event handlers are getting called. But why is it empty though? Oh, oops! I forgot to pass the events while triggering the refresh timer. It's just one letter causing all these problems. Well, that's actually not exceptional in programming, since any misplaced letter could cause chaos. Anyway, now it works again, which means that we did a great job today. It also magically solved the problem that we had earlier while saving primitive meshes, and that makes me extra happy. Now that we have polished the content browser, we can also try and use it for saving primitive meshes instead of using the default Windows control. You will have to be patient though, because that's what I'm going to do in the next video. I hope you enjoyed this video and learned something new. As always, thank you for joining me, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering.